All right, here we go. Essential question. How do you find the area of an equilateral triangle? That's right. I'm going to actually teach you this in an example, which is going to be fun. Here's the given information. ABC, that triangle, is equilateral. So you see it ABC, equilateral. And BC, one side length of the triangle is 8. So you see that right there. The question is to find the area. Smiley face. Well, it is just a triangle. There's nothing more to it. So we already know this. The area of a triangle is 1/2 base times height. So all I have to do is find the base length, and I have to find the height. Well, as you see, I've already plugged in 8 for the base because that is actually already given to me. Now I know in the given triangle, that right there is the actual 8. Well, remember, an equilateral triangle means all 3 sides are exactly the same. So either way, they're going to be the base. Remember, the height when you draw it in a triangle determines where the base is. But regardless, the bases are all at 8, so it's going to be 8. So what I have to do is find the height to find the area of this particular triangle. Well, here's what I've done. I've drawn an altitude down here. And as you know, an altitude forms right angles. What happens is you can easily, pretty simply, prove that those two triangles are congruent, which makes these little pieces A to that point right there. And that point right there, C, makes those two pieces congruent. We've seen that a bunch. But that's important because of this. That means if this whole segment AC, which is 8, which is the base, if I take that and divide it into 2, that means each of those are 4 units each. So here's what's neat. There's 2 options here. You see that this is a right triangle. The triangle B to that point over to C, that's a right triangle. Oh, I have a leg of the right triangle, and I have the hypotenuse. So let's use the Pythagorean theorem. That's what I've done right here. A squared plus B squared equals C squared. The one leg is 4, so I plug it in for either the A or B, doesn't matter. The C, that's the hypotenuse, so I put 8 in for that. I do the math real quick. You get 4 squared, 16, plus B squared equals 64. That's cool. B squared equals 48. And then as you know from algebra, you algebrainiacs, what you do to one side of an equation, you must do to the other. And the inverse operation of squaring something is square rooting it. So I square root both sides. That's what happened here. And then it gives me actually plus or minus. I don't have it written here, but remember, it's plus or minus the square root of 48. But the minus 48, the negative 48, doesn't make any sense because we're talking about the side length of a triangle. So that's disregarded. It's called an extraneous solution. So it's gone, but we do have the positive 48. So when I take 48 and divide that up into 2 factors, where one's a perfect square, remember we talked about this, 16 is now a perfect square. So once it becomes perfect, it's freed. It's out of jail. So the square root disappears, and the square root of 16 is actually a 4, not the square root of 4. Square root of 16 is just 4. Remember, it's free. It's out of jail. So 4 is that. Square root of 3 just stays square root of 3. So there is what B is. Now don't get confused. I don't want you to think this B is exactly what this B is. It's not. Oh, I know it's the same letter. But B here stands for the base length of a triangle. This B stands for the leg length of a right triangle. So it's different. Just a variable, whatever. It's just what's being used. So that means this piece, the altitude, the height, is 4 root 3. So that means when I multiply this, I get 1/2 times 8. This gives me 4. The height is 4 root 3. That gives me 16 root 3 units squared. And there's your answer for the area of this particular triangle. Now some of you might be sitting there thinking like, wait a minute, I didn't use Pythagorean theorem. Good, you didn't have to, because if you look at this, an equilateral triangle is also equiangular. So all these angles are 60. So therefore down here, this is 60. Uh-oh, 60 and 90 means I have a remaining angle measure of 30. Whew. So I'm looking at a 30, 60, 90 triangle. Sweet! So that means this. That means across from my, that means across from my 90-degree angle, my 30, 60, 90 is the 2x. Across my 60-degree angle is the x root 3. Across my 30-degree angle is what x is. Wait a minute, I have it. X is 4. So if x is 4, that means this has to be 4 root 3, which is exactly what I got for the height anyways. So either way, sweet, we got it. So let me show you this though, because that is certainly one way that you can find the area of an equilateral triangle, or any triangle really. But since it's equilateral, there is a special formula for it. And here's what you can do. This will work. One option is Theorem 106, and Theorem 106 says this. The area of an equilateral triangle is side length squared, and that's what the S stands for in an equilateral triangle, the side length. Just like it did back in a square, because all three sides are the same, all four sides are the same in a square. So S squared over 4, and then you just attach the root 3 to it. I know it looks weird, but I'm going to tell you, memorizing this saves you a tremendous amount of time. So what you could have done in the example before, when this was given to you to be 8, that's a side length. So all you got to do is plug it right in there for the S, which gives you this. So then you just take this expression and simplify it. So 8 squared is 64. 64 divided by 4 is 16. And, oh, look, you're done. Nothing more to it. So either one will work, but as soon as you see equilateral triangle, you should be thinking, let me use this formula. Because all you have to do is find the side length, plug it in for here, and you're done. But something that is kind of cool is it says, hey, cool, look at this. Remember, you can also still use the formula for the area of a triangle. It still is a triangle. It just is a special one. So let's do an example or two. I'll show you this all kind of plays out. And here we go. Example, find the area of the equilateral triangle. So here it is. It's a simple equilateral triangle. The side length is 4 root 6. Well, you could do exactly what I just did before. You can draw the altitude. You can realize that this is a 30, 60, 90 triangle then when you draw it, and then figure that whole stuff out. You can do that. However, why don't we use the formula / theorem we just learned? I'm going to use this one. S squared, the side length is 4 root 6, so 4 root 6 I put in for S. And when I square that, you must be careful, because when you square 4 root 6 in your calculator, make sure you put parentheses around it, because if you don't, you're actually going to get 24 if you don't put parentheses around it. If you put parentheses around it, you'll get 96. But just a little closer look, as it says over here, how does that work? Well, 4 root 6, remember, 4 root 6 squared is the same thing as 4 root 6 times 4 root 6. Just like this, if you do 4 squared, that's the same as 4 times 4, or x squared, the same as x times x. Well, 4 root 6 squared is the same as 4 root 6 times 4 root 6. And as we talked about many times, what's outside of jail, you can multiply. What's inside of jail, you can multiply. So 4 and 4, you can multiply to get 16. Square root of 6 and square root of 6 gives you square root of 36. 36 is a perfect square, sweet. So the square root of 36, it's free. It's out of jail because it's a perfect square. It became perfect. So this is 6, so 16 times 6 gives you 96. So that's how that works out mathematically, algebraically, in terms of all the steps. If you don't get it in your calculator, again, make sure you put parentheses around it. So regardless, that means this is 96, back to this, over 4. 96 divided by 4 is 24 root 3. And you're done. That is the answer. Unit squared, of course, and we'll go from there. So there's that example. That's cool. No